Electronic Specifier.
Welcome to Electronic Specifier Insights, the podcast for electronics engineers. I'm your host, Paige West. In today's episode, I speak with Chris Engels, Product Marketing Manager at Tria Technologies. Now, Avnet recently announced the launch of a new product brand, Tria, and a corresponding business called Tria Technologies, with the aim to consolidate its compute design and manufacturing. Chris chats with me about the new brand, what its focus is, and what it means for customers. He also introduces the first product under the new brand, the Com Express Type 6 carrier. We hope you enjoy this episode. Let's get started.
Electronic Specifier.
Hello everyone, and welcome back to Electronic Specifier Insights. I'm pleased today to be joined by Chris Engels, who is the Product Marketing Manager at Tria Technologies. So, hi Chris, thanks very much for joining us, and how are you today?
Hello, thank you very much for the invite. Pretty nice, thank you.
Good, it's a pleasure to have you. So why don't you tell us a little bit about yourself and your background, Chris?
Yeah, I'm in the embedded industry since, I would say, over 30 years now. I've started a career as a hardware developer and used to design embedded computers for industries. And then at a certain point in time, I became part of marketing teams and had different positions inside marketing teams throughout the years. And mostly of them were really focusing on product development and product introduction into embedded industries. And for Tria, I'm a product marketing manager for Com Express and Com HPC products.
Okay, fantastic. So to give our listeners a bit of background, Avnet recently announced the launch of a new product brand, which is Tria, and the corresponding business called Tria Technologies, with the aim to consolidate its compute design and manufacturing. So can you elaborate a little bit more on the motivation behind consolidating the embedded compute offerings under this new brand?
Yeah, sure. I mean, looking at the former Avnet Embedded, I mean, it was consisting of 4 different groups inside that organization. So there was a company called Vitekio, which is certainly still there, focusing on professional software services. Then we have a display group, which is introducing new products based on display technology into embedded markets, and they rely on suppliers from Asia. Then there's also a distribution group, which actually provides embedded solutions from third parties into the embedded markets. And then there's that branch where Tria now is the name, which solely focus on development and production of own products. And that group has been separated from the other groups and became, by the rebranding, a new company called Tria Technologies. And it's as I said, it's completely focusing on defining and developing and producing own products, mostly all around open industry standards like SMART, Com Express, and the like, so the modules, but also on developing system solutions, integration of systems. And Tria is also a manufacturer, so they have our own production sites and different locations, and so we can provide modules and complete solutions to customers. The focus is really on getting this all together under one umbrella, under one brand, in order to make sure that customers and also sales partners understand that this is an own company which does their own business, with their own product. If you look at the other possibilities you could get from Avnet Embedded, there's obviously also other products from other suppliers. And with that separation, it becomes more visible and transparent to every participant that what we are focusing on and what probably other parts of the company would focus on.
So is there a particular gap or opportunity in the market that Avnet is aiming to address?
Well, I mean, the opportunity is certainly always there. I mean, embedded markets are always large and there's always possibilities for new opportunities. But I think we, as a manufacturer and developer of embedded solutions, we are very well positioned. We have a very large product portfolio of different module standards, and not just the standards themselves is the broad product portfolio, but also the possibilities with different CPU architectures from ARM and x86 from different CPU suppliers. So that is a probably the largest product portfolio, particularly on SMARC, what the company can provide, and together with the possibility to produce that in-house and the expertise from the support organization and the engineering organizations. So we have different design centers. All this can help to provide products into customer opportunities much better. And I said, having that separation, then there's a clear interface for customers with whom they can work in order to get their solution from the supplier.
Mm. And speaking of your sort of broad portfolio, how will this new brand help Avnet sort of differentiate itself from its competitors in the embedded compute space?
Yeah. So, I mean, in the perspective of Avnet, I would say, I mean, Avnet is much larger than Tria, obviously. And by the way, Tria is still part of Avnet. We're still a daughter company. But Avnet is focusing on distribution. So they distribute different components and modules and entire solutions. It was not so clear for the sales force, but also for customers from whom the product would come, right? Who would be the supplier behind. And I mean, with the separation, the visible separation into an own company, it becomes much more clearer to the sales force and to customers. Is the solution from Tira? Is it from one of the competitors? And so I think it just makes things easier for the sales force from the Avnet perspective. And we at Tria also have clear boundaries there and say, okay, this is an opportunity which goes to a competitor, well, because they have probably the better choice, or it was picked by Avnet. And then on the other hand, we don't get any requests which are not related to our own products, which sometimes happened as well. Right? With our support team, sometimes we were engaged for products which were not actually coming from our house.
Mm. And what about existing customers? How will the new brand affect those who are currently using Avnet's embedded compute products?
Yeah, I think, I mean, there's not so much of a change for them. I mean, existing customers are used to a specific service quality they can expect from us. I mean, as I said, there's large product portfolio. We also have a very excellent support team, which can help customers in their design-in phase. So they continue to get this kind of service quality. It probably helps us because, I mean, we sometimes heard from customers, oh, Avnet, we didn't know that you do your products on your own, right? Mm-hmm. And I mean, because customers are used to work with a distributor called Avnet, and for some of them, actually it was a surprise hearing that. Having now an own brand, and hopefully that brand becomes more visible in the market and more recognizable, I think it's also for customers more clearer. Okay, if I go to those guys, they will offer me a product which they have developed themselves, which they know, which they can support me. So I think, yeah, customers will, in the end, will benefit from that as well.
Fantastic. So let's talk about the first product under the new brand, which is the ComExpress Type 6 carrier. Can you provide some more details on its key features and how these help accelerate system development for engineers?
So yeah, it's a carrier. So I'm looking at ComExpress being part of the computer on modules approach. I mean, you have to have a module and you have to have a carrier underneath in order to operate the module. So it is an essential element you need to provide to customers in order to help them to bring up the module and doing first testing. But for the carrier itself, so from the product features, it's a little bit designed with the expectation on specific products we have on the module side. And over the years, the interfaces which are provided by processors on these modules, they have been enhanced. And we have, for example, we have PCI Express Gen 4 coming out of the processors, and which is also supported by the ComExpress specification. There's Ethernet. It has been there for a long time, being 1 gigabit Ethernet. Meanwhile, a lot of the silicon content can actually do 2.5 gigabit Ethernet. And for the older products we have on carriers, they did not support this type of bandwidths. So that's basically the enhancement we have done to the carrier design, and which are actually supporting newer module generations with that respect. how does it help customers? I mean, there are two different types of customers. There are customers which may have already a carrier design on their own, and then maybe just taking a new module generation and plug it in and test them. So they're probably perfectly fine with what they have. But there's certainly also customers starting a new generation of product, and they're looking first time into Com Express, or they're moving from a smaller Com Express standard, they come Type 10 to the Type 6 interface, and they need to start from scratch. And I mean, the modular approach makes things much easier. They don't need to care about the processor function on their own, but they need to develop the carrier, and it's still a complex beast, or can be a very complex depending on what type of application needs to be enabled. So a carrier, in the first instance, helps to test the module from the supplier. Does it fit my performance needs? Does it have the right interfaces? How do they behave? Can I test specific I/O already in my lab environment? So that's one purpose. The other purpose probably is that while a customer does a known carrier design and they don't have the hardware in place, they already can develop software, so the target or application software. That may not be the full setup of an entire application in the beginning, but they may just test specific functions with the new software, and they can do concurrently while they're waiting for their own hardware to be ready. So these are probably two of the main purposes. What we also do is we're actually providing the schematics of the carriers we have to customers when they're asking for that. And those schematics can help actually to accelerate the own development of a carrier. The specific interfaces they want to enable, they can to look into our reference schematic and see, okay, the guys have it done that way. Maybe I try that way as well, or as a specific support chip which has been used, and they selecting the same silicon content. So that's I think that's another very important item. And then also what we can offer also is once a schematic is completed, customers can provide us the schematics for schematic review, and our engineers go through it and review those portions of the schematics which are related to the module function. And then we can provide advice to the development engineers from that customers. So in a nutshell, that's all what a carrier can do, and it becomes a very important tool. It's not so much a revenue generating product, it's more a tool which helps customers to accelerate their own development process.
Okay, are there any sort of particular industries that you foresee benefiting the most from this new carrier board? And perhaps you could give us some examples of applications that would be particularly useful.
Yeah, I mean, Com Express is surprisingly widely used in many different kinds of applications. It can be, in public transport, in digital signage, in medical equipment, in industrial control units, so many different applications where it actually has been implemented. But certainly when you look at our product portfolio, we do have high performance CPUs on x86 architecture, and those are probably more interesting for performance hungry applications. You will find them, for example, in medical equipment, or in now starting artificial intelligence applications becoming more popular, interesting for embedded applications as well. And the CPUs are there. And in combination with the carrier, those applications are probably more of interest. We do also have some smaller or less performance CPUs, but more cost-effective CPUs, and they're probably more interesting for transport applications. And here also the carrier could help to enable those kind of applications.
Mm-hmm. So given your experience in the industry then, Chris, what are some of the biggest challenges that engineers face when trying to accelerate the prototyping phase? And how can tools and platforms like the one we've been talking about help them overcome those obstacles?
Yeah, I mean, sometimes what we see, it's certainly always a customer decision, but sometimes engineers, they love to develop everything themselves, right? Starting from a CPU building block and all the ingredients they need, and put that on one board. in some application, I mean, this works pretty well if you have a small microcontroller as such, and then that's probably the perfect approach. But if you have a complex CPU, and in many of these applications, I would say the expected annual volume is not that large that a team could afford to do a complex CPU design on their own. And probably also the design teams are just not large enough, and the budgets may not be large enough in order to justify that. That's where a computer on module approach comes into place. And I mean, that's a fundamental decision the customer must do themselves. And if they say, okay, we can't afford that and we want to accelerate our own efforts, let's go with a module approach. That I think that's the most important decision in the beginning. But what we sometimes find out is that customers started to develop something and they were not aware that there's a reference carrier. They were not talking to our support and design engineers, and they were just developing. And then they come with a piece of hardware and they try to let it work with the module, and then for whatever reason it does not work as expected. I mean, this is, as said, this is complex technology. It's not so easy to implement. And I think it's quite valid for customers if they engage us very early in the process. As said, with the reference carrier, with schematic reviews, and start asking the right questions and engage the support team. The support team has a lot of knowledge themselves, so they can answer a lot of these questions right away. And if there's specific implementation details which needs to be checked, then we always have our design teams in the background which can help to answer those kind of questions. Mm. So I think that can help to fasten the process. And a tool like a carrier is also is part of that element.
So how does this carrier board fit into Tria's sort of broader embedded compute portfolio? And are there any complementary products that developers should consider?
Yeah, I mean, as I said, we do have some products in the portfolio which have high performance capabilities. Namely, these are the products based on the 12th and 13th generation of Intel Core CPUs. For example, we have a compact Type 6 board based on the Intel Raptor Lake processor. That's the C6 RLP module. So that is a very compact module with a lot of I/O connectivity and a very large scalability because the processor family from Intel is widely scalable from entry processor up to the high-end processor. So that is a very good choice when you're looking at imaging applications in medical, in automation, robotics, and such. And that's is a good support by the carrier card for this class of product. Another example would be certainly also a COM/Express Type 6 board based on the Intel Core Ultra processor, or codename Meteor Lake. And this processor now comes also with AI capabilities built into the silicon already. And that is a good starting point for high-end medical imaging applications. And if customers start to look into AI in the edge, that also would be the right silicon content with the right respect. And then on the lower entry, on the Atom side, Intel Atom processor, we do have the latest generation of Atom processor called Amston Lake. So that's a C6C ASL board. So it's from a scalability, it's below what the 12th and 13th generation can provide, but it's an improvement over the older Atom Lake Atom processors with respect to performance. And that's also a good choice for the carrier.
Excellent. A good overview. Thank you. And I'm sure our listeners would be interested to hear if there are any upcoming plans or future releases under the Tria brand.
Yeah, I mean, there's always room for improvement. What we have not incorporated in this generation of carrier is actually support for USB 4. That's actually has been incorporated into the latest revision of the COM/Express specification. And USB 4 is, on one hand, it's actually a performance bandwidth improvement over older USB generations, but it also provides the capability to tunnel for example, DisplayPort or PCI Express over the same interface. So that is quite convenient. People know it probably from the docking station on the PC or on the notebook. So you have one single connectivity, and then through the cable, you can actually travel different kind of information about over the cable. And that can be a very useful function in also, say, in medical equipment or other equipment where you just easily want to hook a cable to it, and then you have all the necessary I/O connected to it. So that's something we're looking into, future generation of COM Express carrier, which also enables USB Type-C with power delivery for the USB function.
Fantastic. Well, thank you very much for introducing us to the Tria brand. Is there anything else that you wanted to say before we wrap up?
Yeah, I would like to say thank you for the opportunity to talk about the matter. Next week, we do have Electronica in Munich in Germany. So if the viewers have the opportunity to join the show or being on an embedded show in next year, they are invited to visit us on our booths and ask questions and to our product portfolio, and we're happy to answer questions and help finding the right products for the customers' solutions.
Perfect. Thank you very much. Do you know what shows you're going to be at next year, Chris?
Well, definitely there will be the Embedded World in Nuremberg in Germany, which is the largest show with respect to our markets, and we're already in preparation for that.
Excellent. Well, I hope to see you there, and
Yes.
Thank you very much for your time today. It was a pleasure speaking with you.
Thank you very much.
Thank you for listening to this latest episode of Electronic Specifier Insights. Don't forget to subscribe to the series to keep up to date with our newest guests, and do share with fellow colleagues, friends and family who may be interested in the latest news from the electronics industry.
Electronic Specifier.